Alright, so we're asked to find the roots of the quadratic equation 3x squared minus 8x minus 3 equals 0. Notice that roots is another word for solutions. So we're really looking for the solutions for this equation, meaning the values of x that when substituted into the x here, at the end the entire equation ends up being equal to 0. And we know this is a quadratic equation because a quadratic equation in standard form is written down as ax squared plus bx plus c equal 0. Now remember that a, b, and c are just constants. These are just numbers. Now the variables here will be the x squared, and the x, or just the x. So now we're asked to find the solutions for this quadratic equation. There are different ways of solving quadratic equations, but on this lesson we're just concentrating only on factoring. Eventually I'll create a video for using other type of methods. So now we're factoring this trinomial here. So you notice that there's no common factor between them, so we're going to go straight into trinomial factoring. And how do you factor a trinomial? Well, remember that a trinomial comes from a product of two binomials. So now we have this two parentheses here where we're going to write the binomials. Now remember that the first two terms of the binomials have to multiply to 3x squared. So we know that 3x times x gives us 3x squared. We want two numbers now that multiply to -3. This will be the numbers that are going to be placed here and here. So two numbers that multiply to -3. Well, we know that 1 times 3 is 3, so I'll write down 1 times 3. Now our goal now is to focus on this 8 here in the middle, because now we're going to have to figure out the signs of these numbers. So now we have, what we got to do now is multiply the inner terms together. So we have 1 times x, which is 1x, and the outer terms together, multiply together, that gives you 9x. Now remember that the reason why we're doing this is really because of the distributive method when we're multiplying two binomials. Remember that two inner terms, when you multiply them together, and the outer terms at the end combine together to give you that middle term that we have here. So now the goal here is to figure out how we're going to end up getting this -8x using the 1x and the 9x. Well, remember the answer has to be negative. And it looks like we're going to have to subtract the two numbers to get to 8. So if we're subtracting the two numbers, that means that the signs of the two numbers are different. And because the answer is negative, the sign of the largest number must be negative. So I know definitely that the 9 has to have a negative. So therefore the 1 is positive. See, now if we combine a positive 1 and a -9, that will give us that -8. So therefore the sign of the 9 is negative, the sign of the 1 is positive. The 1 came from here, so the 1 is positive. And the 9 came from this two 3's multiplied together. This is the one that is missing the sign, so I'll place the negative on the 3. So we just factor this trinomial. So what I'm going to do now is I'm going to rewrite this trinomial, because I need to, actually this factor form, I need to rewrite it. So I'm going to rewrite it over here. Now we have the 3x plus 1 times the x minus 3. What I want to do next is that I want to solve for x. But you notice that this is a multiplication of two things. Somehow the answer is 0. So remember that if you have some number, call it a, and I'm multiplying this number by some other number, we can call it b, and the answer is 0, that tells us something about one of those two numbers. Because imagine that a is 2. What number should b be so that at the end the answer is 0? Well, b definitely has to be 0 then. That is if a is some number that we know. Now if b is some other number and we're looking for a, well, a has to be 0. So is either a 0 or b 0. one of those two, so that the answer is 0. But now remember, it could be both also. Both could be equal to 0. So the idea is the same here. We know that the product of this parentheses, call it parentheses A, and the product of this other parentheses, call this parentheses B. So we have this parentheses A, this parentheses B. The product of those two is equal to 0. So that tells us that either A is 0 or B is 0. In other words, either this parentheses is 0 or the other parentheses is 0. But what we're going to do is we're going to try to find what values of x will give us 0 for either of them. So either this is 0 or x minus 3 is equal to 0. Usually, you might remember it because usually when they teach you this topic, they write a line right in the middle of the two parentheses and they start solving them. So in this case, if we're solving for x here, I'll be subtracting 1 on both sides. Remember, that's the addition property for solving equations. So now we have 3x, this is 0, equal to 0 minus 1, which is negative 1. Now if you want to get x by itself here, remember this is the multiplication operation, so you do the opposite operation, which means that we're going to have to divide by the number we're multiplying by. So we're divide by 3. Now this 3 divided by 3 is 1, so we're left with 1x equal to negative 1/3. Now if I'm solving this side here, that changes the game a little, because now to solve this, all we're doing is really adding 3 on both sides, and the final answer here, because 3 minus 3 is 0, we get x equals to 3 plus 0, which is just 3. So the final answer for this problem will be x equals 3, and notice that x is also negative 1/3. So both numbers are solutions or roots for the quadratic equation, meaning that when you take these numbers and you substitute them back into this quadratic equation, at the end the answer will equal to 0. Now if you don't believe me, we can actually try checking this problem. So let me just make some space here to do a check. Now remember, this is just a check. We don't really need to do this part just to write the solution. This is just to make sure that our answers are correct. Now I'm going to try the most difficult one, which would be just plugging in a half into the problem, a negative 1/3, sorry. So now I have what I'm going to do is I'm going to substitute the negative 1/3. So I have 3 times, and remember that whatever x is being squared, minus the 8x minus 3, and we want to know if this is really going to be equal to, is this going to be equal to 0? That's what we're asking ourselves. Now we know that we're going to substitute the x equals negative 1/3 here, so I'm going to put negative 1/3 for x, negative 1/3 for x here, and now I'm going to try to solve this. So remember, we have this exponent, we have the multiplication, but we know that by order of operations we're supposed to work with exponents first. So we have negative 1/3 squared, which gives us 1/9. The reason why is 1/9 is because 1/3 times 1/3 is 1/9. Now we have this negative 8 times this negative 1/3, and we're subtracting 3 from it. We want to know if this is going to be equal to 0. So now we have 3 times 1/9. Well, this is the same thing as having 3/1. If we multiply by times 1/9, we can reduce before we multiply. So 3 goes into 9 3 times, and 3 goes into 3 once. So when you multiply across, we get 1/3. Now we're multiplying a negative 8 times a negative 1/3, which gives us 8/3 minus 3. And you're asking yourself, is this 0? Well, we have 1/3 plus 8/3. They have the same denominator, so we can just add them right across. 1 plus 8 is 9. 9/3 minus the 3 that we have here. Is that equal to 0? And you notice that this is 9/3, which is, if you divide them, you get 3. So 3 minus 3 is 0. so it checks. So therefore, negative 1/3 is a root of the quadratic equation we have here, because once we plug it in at the end we end up getting 0. Same thing happens with 3. I guess I don't have to check 3 because I'm assuming that you already know the procedure. Well, take care.